Now we are in homework 5, problem 2. In this problem, it gives us a density function of x and y. It's like this form, and y is no less than 1, and x is more than y divided by y and less than y. So that's the range. That's the range of y and x. So in question 1, we need to draw the non-zero definition region of density function of x and y. So because we have the range of x and y, so we can just we can just draw the picture in the x y axis. This line means y equals to x, and this line is y equals to 1 divided by y. So for y is no less than y. It means that the value of y should be upper than the line. The line that at y equals to 1. So it's like this form. And for x is more than y divided by y, so it should be like in this range. And for this it's like this. So so combined with them, we got the range, or we got the region. It should be like this. So that's the question 1. It's very easy. And now for question 2, we need to find a, the big A, so that the density function of x and y is a valid joint density function. So according to the definition, for the density function should be a valid joint density function. Is that this equation should be equals to 1. So we just calculate this, and we got this. We just need to divide the case, and we calculate x and y, and then we got this. It's just a transmission problem. And finally, we set alpha, and alpha is equal to lambda y, and y equals to this. So we put this into this equation, and we got the integral transmission of the density function of x and y should be like this. And finally, we got this, and it's just a series of calculation and of the integral transmission. And finally, we got 2 divided by the big A equals to 1. So A equals to 2. So it's the problem of calculation of the integral transmission. And in the third question, we need to find and draw the marginal density function of the density function of x and y. So it's just that according to the definition, the density function of x should be the integral transmission of the density function of x and y, and we need to transmit y. So the density function of x equals to this, and we need to divide it each case. So for x less than 1 and more than 0, it should be like this. The smallest value should be 1 divided by x, and we put this value into this, and we got 1.5. And for x, it's more than 1, and the smallest value should be x, so we put x into this, and we got this. So that's the whole thing of the marginal density functions of function of x, and we can draw the picture. It's like this. And for the density function of y, we just use the same way, because y should be, because we know that x is the range of x is like this. So we put these two values, y y and 1 divided by y into this transmission equation, and we got this. And for y should be no less than 1. So that's the marginal density function of y. And for the question 4, we need to verify the fx and fy are valid density function. So we can combine these two questions. According to the third question, we know that we have known that the equation of the marginal density functions. So just calculate this, and we put these two results into this transmission equation, and we can get this, and the value of this should be 1. So fx is a valid density function. So we use the same way to calculate the density function of y, and we also got the value, the result is 1. So therefore both of the density functions of x and y are valid.